Guys, this is just another video to help you understand the area of a circle and how we get the area of a circle. Now, you've got that formula pi r squared that hopefully you've run into by now and that maybe is stowed in some part of your brain. And you might know how to use it, but you might have no real concept of why it is what it is. Well, there's much better, more mathematical explanations out there that I'll show you and that I'll sign you. But I want to throw this one at you because it's got a common sense appeal to it that maybe is just, a little bit easier to understand. One thing you might remember when we're talking about similar figures, that all circles are similar figures, but also that all squares are similar figures. And it's actually the case that if you take a circle and you inscribe it inside a square, that just means that the circle is tangent to the square on all four sides. Remember that word tangent means just touching the sides on all four sides. Then it's always, always, always the case that the percentage of the square that the circle will take up is always going to be the same. And so if you could just say, well, if I look at this circle here, I've got a diameter. Notice that however long the diameter here is also the same length as one side of the square. In fact, it's the same length as all four sides of the square. Then I could get the area of this square, which is just diameter times diameter, or diameter squared, and that'll give me the area of the whole square, right? And if it's true, like I just said it was, that a circle always occupies the same percentage of a square that it's inside, then I can always just say, well, let me take the diameter, square it to get the area of the square, and then multiply it by that percentage, and then that'll give me the area of the circle inside the square. So you can do that. And if you want to know what that percentage is, well, like I told you, it's the same for every circle inside a square. This is that percentage, 78.539816339744831, and the numbers keep going percent. So you could say, well, let's say I can see the diameter of this square if we're considering each of these little squares to have a length of 1 centimeter, then that's going to be 10 centimeters for the diameter. That means 10 centimeters for one side of the square, 10 centimeters by the other side. 100 times 78 point blah 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 percent gives me an area of 78.539816339744831 centimeters squared. And so then you say, well, if that's the formula for the area of the circle, why don't we just use that instead of pi r squared? Well, you do use pi r squared. Watch. If I look at the radius here, right, the radius is 5. And if I take 5 and I multiply that by 5 again, because the formula is to square the radius, then I get 25. See all these little squares here? This little square in the top right corner, you can count them. There's 25 little squares here. It's 25 centimeters squared. That's the area right here. And I know if I multiply that by 4, I'll get the area of the big square. But instead, I'm going to multiply it by pi. Right, I'm going to take this 25, I'm going to multiply it by pi, and that's going to give me the area. Well, watch what area we get. Wait a minute, what is that? No, that's the exact same number we had before. That is the same area. So why is it that if I do radius, and then I square that to get these 25 squares, and I multiply it by this random number 3.14159, that I'm getting the same thing as if I just get the area of this square and multiply it by the percent that the circle takes up? Well, it's because that percentage I was telling you about, that 78.539% that the circle occupies, that number, let's turn it into a decimal first. If you turn this into a decimal, that percent I was telling you about, that percent is just the same thing as pi divided by 4. So they're actually the same formula, because you see there's 1, 2, 3, 4 of these, and if I multiply that by 4 and I multiply it by a percent, I get the same thing. Now maybe this makes no sense to you, but really what I want you to understand is that the reason why we multiply pi is because pi over 4 just gives you the percent of this big square that the circle takes up, and that's why your formula is pi r squared.